presentation, just like last time. Thank you. I wish we would have compared notes before because our presentations are going to be complimentary. And I've got to steal that line from you. I'll give you full credit, but you said in the beginning, we're not in an age of artificial intelligence. I believe you said we're in an age of artificial insanity. That is a classic line. Thank you for that. And congratulations in advance on your Winnipeg Jets, who I think are in first place. My Los Angeles Kings are in last place. So here we go. Let me share my screen here. Let me see if I can figure that out. There we go. We'll share that one. This is a variation of a keynote that I do that is based or is titled "The Ethics of Artificial Intelligence." Go. Are you seeing my screen? Probably. Hang on, bear with me. PowerPoint issues. I think if I do this and I do this, yeah, I think now you're seeing my screen, right? Okay, good. So I'm a technical guy. I normally do keynotes to technical audiences, developer, IT, things like that. In fact, I did a live presentation, believe it or not, in Europe last week to a huge audience, which is, this whole pandemic thing has been awkward for me because I wish I could see your faces. It makes the presentations, at least for me, I think I'm more effective when I do that. But I'll manage to do this. I've been doing this a long time. I worked at Microsoft when I was a young man. That's where I learned how professional software is built. But also I was the kid that did the demos for the big guy. No one ever saw me. They saw Bill Gates and Steve Ballmer and Satya Nadella and a whole bunch of Microsoft executives. I am not a Microsoft employee. I'm more like a hired gun with an expertise in artificial intelligence. So here's what we're going to talk about today. I'm going to try and complement Stacy's presentation as best I can, and I think I can do a good job with it. We're going to talk about the effects of AI. I'm mostly going to focus on where we are now and where we are going. I'm going to talk about the risks. I'm going to try and augment the risks that Stacy elaborated and the benefits. And I'm going to show you, I think I'm going to show you some shocking things about where we are in AI and how easy it is to do this and how powerful and scary at the same time that might be. And then I'm going to talk about the ethics of artificial intelligence, because in the hands of bad guys, this could be damaging type of stuff. And if you remember me from the last time or know me from technical presentations, I'd love to do live demos. So we're going to do that too. You most likely don't know my name or the companies I founded. One of the reasons is we build software for other companies, all custom. And because of that, unfortunately, most of the work we do is covered by NDA, so I can't really talk about it. We build some really high-tech software, and we've been doing it for over 20 years. The client list is impressive, spanning a good fortune of the F1000. I think the marketing people, there's some of the many gaming, I guess I do that, some of the many companies in the gaming industry that we've built software for over the years. So let me get through this uncomfortable about Tim stuff. Here's a bunch of famous people using the software we've built. We've been lucky to build a lot of software for the hospitality industry, which is the industry you live in, gaming and casino. This is Hollywood. You'll be familiar with this. Everyone in the free world has seen this. This is the application that is the ultimate in data visualization. Over 250 million people at a time worldwide experience this piece of software during the United States presidential elections, and pretty much 3 or 4 times a week, because that is the flagship app for CNN and some other entities. Okay, let's jump in. From cancer research and detection and Stacy's work in breast cancer detection. My wife's a breast cancer survivor, so I can't wait to tell her about that. to rare disease identification, to machine learning on the human genome, to COVID-19 detection and recognition. AI does save lives. It saves lives right now, and it's been saving lives for years. I'm proud that I've been working in computer vision, which is a segment of AI, and 3D based solutions for solving cancer for over a decade. Um, I'm not going to play this video. I don't have enough time, and it's not really appropriate to casino and gambling industry, but it's me doing a pre-pandemic keynote at a huge Microsoft conference. My part's too long in this keynote. We just don't have enough time, but I've embedded the link to the video, and it's in the case study, and it's in this PowerPoint deck, which reminds me to tell you, if you want my PowerPoint deck, you are more than welcome to it. A lot of people use my decks to, discuss ideas within their own companies. I'll have a link where you can download it at the end of the presentation. It's worth checking out because it's a great story, a story I love. I met this amazing woman. Her name is Melissa Mulholland. She's an executive at a huge European software company. Her son had a rare syndrome in vitro called pulmonary urethral valve syndrome, PUV. It's a fairly easy procedure to fix, but if not diagnosed, it's 100% fatal. And it's a rare disease. So not all physicians are trained to recognize it in ultrasound images. And if they miss it, it's fatal. I had a hunch I could build a computer vision model to recognize this syndrome in ultrasound images with an API that's publicly available. So I got the real images from her son, and I got some training images off the interweb, and it was one of those times where I was so heads down and concentrating. At 3 a.m., I had a prototype done within 24 hours that worked flawlessly, and the solution has been well publicized. Here's another demo I'm not going to do, but you can do this one for yourself. This is COVID detection. This is some work we did early in the pandemic. This is another project of ethics, what we call these projects of ethics, that I'm so proud of. I got to tell you, I got to sneak this in, that we have built software for the company that's killing the world with their cheeseburgers. I got to keep the lights on. So, but these are the projects that I'm proud of. This is work done with the same API I used for PUV. I'm going to do a demo of it to show you how easy it is to do this stuff later in the presentation in just a few minutes, because I got to go fast. This research and its proof of concept app was published by a group of doctors and scientists about a year ago, maybe a year and a half now. And since it was the first in the space race to recognize COVID in X-rays, it got a ton of attention. The good folks at Stanford did something after it, kind of made it a similar thing, and they got great attention too, obviously. Now, check this out. This should be fairly surprising, shocking for you. If it's not, you're savvy to computer vision and AI. This is the work we did for an ISV. ISV is an acronym for Independent Software Vendor, I think. Anyways, big software company in face detection. We called it the multi-scale face detector. I don't know what they call it. If you think this through, it's a bit staggering. I feel like this may bore you. You may already know this, or this may be interesting. HD quality video is simply 30 pictures strung together. We call those pictures frames, so 30 frames per second. In computer vision, we analyze a frame of the video feed, and we try to do it in real time as fast as we can in computer vision. I still haven't seen anything better than this for face detection. In this example, it's literally identified hundreds, if not thousands, of faces in one single picture, which could be a frame of video. Now realize all it's doing is face detection. It's not processing the face in any way. It's not doing a facial recognition or a demographic profile on the face or anything like that. If you wanted to do this detection and then process each face identified in this one frame of video with trained algorithms and do it in real time, you need one heck of a powerful computer. But that's the type of power in the CPU that we're getting. And I'll talk about that in a bit too. And that's the type of power that we're getting that we can do in real time, practically almost at the speed of the camera, which is in HD, 30 frames a second, and some nicer cameras even faster. Face detection's the hard part. Face identification, frequently called facial recognition, is a solved problem. It's easy. It's been solved for years. So what is fairly new is compute power, and that translates into trained machine learning models with amazing accuracy. Facial recognition, frequently called facial identification, again, is a solved problem. It's been solved for years. It's been worked on for over 25 years. The accuracy we get in facial recognition in common algorithms, some of them free, is ridiculous. NIST, the National Institute for Standards Technology, every 4 years, this entity does standardized testing on facial recognition algorithms, among other things. The latest tests were back in 2019. It included hundreds of facial recognition vendors like NEC, the biggie. Let me talk you through interpreting the two results that I've pasted into the slide from the NIST testing. On the top is absolute accuracy. In look who won. I find this shocking. Microsoft, for the first time in history, it's the first time they've ever submitted to NIST. Understand that NEC has dominated this testing. That's what is looking at you in an airport, the NEC software. They've dominated this forever. You're staring top left at 99.94, 99.81, and 99.73% accuracy in facial recognition. On the bottom is the gains in facial recognition accuracy since 2013, so almost 10 years. I mentioned that NEC has won this thing forever. Well, since 2013, we've pretty much jumped from 96, 97% accuracy to 99% accuracy in facial recognition. All right, so let's do a quick little demo here, and I have to tell Zoom that I don't want them to grab my video. Okay, I've turned my face off, and I want to do this. There we are. All right, you should be seeing an application, and I want to do this one. Okay, and there's me. Notice quickly right here, it's done a facial recognition on me with 95% accuracy. It's saying I'm 56 years old. Oops, it's saying I'm 58. It's saying I'm actually 59. And there it just went. It showed me at 59. That in itself is shocking to me, and it should be to you too. But what's even more shocking and maybe even more controversial is this application is in open source. You or your developers are welcome to this source code for free. And the services it's using in which are in Microsoft's cloud called Azure are free to build solutions on. Just think that through. Any 12-year-old could build a version of this application that does facial recognition. I'm not here to tell you whether it's good, bad, or different and have my own opinions, but that's pretty surprising that technology this good is in the public domain. It's also doing a demographic profile on me. Notice it's pinned me to the male gender. And there's Microsoft's disclaimer that it can't recognize all gender types, of course. And then it's also doing a emotional profile on me. Happy, sad, angry, things like that. We do this in your industry in the security space because there's some really smart scientists that can take the components of what we get in computer vision, like 20% angry, 30% sad, and 30% surprised, and work that into algorithm that is propensity to steal, propensity to commit suicide, things like that. And that's why some companies in a security context are looking at your face. Okay, quick little demo. Let me get back to slides, and we'll go quickly because my time is so limited here with you, friends. So did that again. Okay, I think you're seeing the right thing now. There we go. So here's a question that really has no answers. If cameras were looking at you in public places, say your casino patrons, would you feel like your privacy was invaded? The government, it's been proven, not just by the United States government or governments of North America, but worldwide, that the government has been caught looking at you, violating their own privacy laws, to analyze your images of the face against their bad guy database. And their bad guy database is significant. It has terrorists in it. It can do an emotional profile, which I just talked about. In your casino, Stacy did such a good job talking about use cases in the casino. Some are completely machine generated, right? You're looking at how the machine is being used. But if you want to determine who has the potential to be in the loyalty program for the casino, ultimately you're going to have to identify that person. Do you feel like, do your patrons feel like their privacy would be invaded? Who knows? Some do, some don't. You can look at the face, but not process it. Like I told you about facial identification. You can apply numbers. The facial recognition tech we do, once we grab that frame of video, we crop all the faces out of it, and then they're turned into a mesh, ones and zeros, and that picture is immediately thrown away in real time within milliseconds. And then there's, the pandemic related things. Buildings are having cameras look at people to see if they're running a fever. It's just simply a byproduct of the pandemic. And I think it's been super interesting how we've relaxed privacy law, at least in the free world. We've relaxed privacy law for pandemic-like reasons. And it'll be interesting to think when we get through this pandemic, and God, I hope it's by next summer, which the experts are saying, how that might change again. So how did this AI thing happen? Sure, there were significant achievements in software, and I'm a software guy. I know very little about hardware, but really, this revolution came about because our CPUs got more powerful, ridiculously powerful, and continue to get more powerful at a shocking pace. This is my hero. He's still alive. He's retired now. This is Dr. Gordon Moore, founder of Intel. I've never met him. I would love to. He made a prediction that they call Moore's Law, an uncanny prediction that has continued to be accurate for 57 years. Really, what it was is he saw a trend where we were cramming twice as many transistors on a circuit board every 2 years. He originally said it was doubling every year, but he later refined that to every 2 years. And why is this? And that equates to CPUs. And you'll see in a graph here, in a visualization here in a second. Why is that important? Because software like machine learning and artificial intelligence ultimately reflects the capability of hardware. Take a look at this, top left. That's 50 billion transistors crammed on the current Intel Gen CPU. 50 billion transistors. And if you look at the call out, I actually did this slide. I didn't depend on marketing people, but I got a new iPhone solely because I'm a fly fisherman and I dropped my cell phone in a lake, so I had to get a brand new iPhone. My iPhone is right up there. The CPU on my iPhone, on my telephone, has 50 billion transistors in it. That's just mind-boggling. So let's talk about what that might mean. Here is this. I pilfered this slide from the Intel CEO. I work a lot with Intel. Love that company, even though I don't know a lot about hardware. But the Intel CEO did a presentation yesterday, day before yesterday, and this is his slide, and I pilfered it, but it has source data on the interweb, and he projected the power of his CPUs. I just said we're currently at 50 billion. Notice the intersection with a trillion on top. That's a trillion by 2030. A CPU with a trillion transistors crammed on it. Now this is super interesting. At least I hope you think it's super interesting. Here's Moore's law, mapping CPU calculation speed against the calculation of speed of the brain. Top right, notice our current CPUs calculate at the speed of the brain of small mammals like rabbits, rodents, things like that. Top right, very top right, also notice that if Moore's law continues to execute, and there is no indication that it won't, our CPUs will calculate at the speed of the human brain by 2025. 2025. That means top left, our CPUs will be calculating at 10,000 billion calculations per second. Does that mean computers will be smarter than humans? Does that mean machines are taking over? No, it's just a predictions that machines will be able to compute as quickly. But what does that really mean? So let me do a little demo and show you what that could mean. All right, so we want to do this. This is what I want you to stare at. This is Microsoft Azure. This is the custom AI portal of Microsoft Azure. What does that mean? It's a poorly named product. It is their object recognition portal. This isn't about looking at faces or humans or body counting or looking at temperature. This is about recognizing common objects, right? Ultimately, when I do these keynotes to technologists and software developers, I talk about that intersection in 2025 when our CPUs are so fast and we get closer to making a blind man see. Imagine a world where a blind man is wearing some type of fancy glasses that has a CPU in it and is doing computer vision and telling him everything in front of him. That there's huge problems with that use case, right? It would be an overwhelming amount of data that couldn't be consumed. But the fact that they could do it is pretty impressive. So I want to tell you that without any coding, I went up into this portal and for free, I took pictures off the interweb of 29 Pepsi bottles and 34 Coke cans and Coke bottles and Pepsi cans. And I just said go. In a technical audience, I would intimately go through how all the bells and whistles of this thing, but I just said go, and that trains the computer vision model up in very powerful computers in Microsoft Azure, and gives you a model with an API that you could use in your own application. So let me just show you. I'll do a quick test of its performance. Oh yeah, here's some stuff I pulled down yesterday. So this is some famous boy band guy. I'm sorry, I don't know the name of the band. I'm not very savvy to pop culture, but you can see right here, it has nailed that Pepsi can and said, I'm 93.7% confident that it is a Pepsi can. In the casino floor, you can imagine the upsell capability for this type of thing. If people carry around Cheetos or even we've been asked to do some interesting thing like looking at the actual cards or chips or things like that. Let me do another one just for fun. How about a kid with a Coke? There we go. And you can see with 94% accuracy that it's pinned this Coke. You could use this portal to look, to determine birds or animals or plants or trees or something like that, or something more applicable to your own industry. I just wanted to show you this thing because it is so darn powerful. While I'm here, let me do another demo, bang out another demo really quickly, because I think it's also important to the make a blind man see thing. This is that same application that's in open source. This time I'm going to use the Vision API, and this is a standard one that I use frequently. What's important here, it's pulled out the facial stuff for 33-year-old male, which underwater is fairly impressive. It's also pinned that, this is a person in the water, right? But look at this, a person swimming in a pool. I think that's pretty darn impressive that it can do that type of recognition in context. What the heck? I've never done this before, but let's try this. So it's taking a frame of the video and analyzing, son of a gun. Because I'm in this facial recognition database, it's Tim Huckaby sitting in a room. Let's do another one just because I'm having fun. Let's go out to my local drive. Let's see if I have something interesting here. Oh, I talked about Stacy's hockey team. So this is my son's hockey team. Let's see if we can figure this out. I've never done this. We're just winging it here. And it's clearly having trouble. Super interesting. A group of people posing for a photo. That I would call that the imperfection of computer vision. I would have hoped it would have figured out, because there's skates, that this was hockey, and there was, there's a trophy that it was figured out that it was some type of championship, things like that. So if I haven't made the point already, there's nothing better than the human eye and the human brain. And we won't even be close to that for many years. There is inherent weaknesses in computer vision and AI in general. I should also say we don't need subtitles. I can't believe we keep needing to do this. There we go. I should also say that AI, especially computer vision, just helps the human make decisions. It doesn't make decisions by itself, or at least it shouldn't make decisions by itself. I need to get back to where I was. Here we are. Oh, and I probably should tell Zoom that it can look at me again. There we go. So it's looking at me again. All right, so to put some of the issues of artificial intelligence in terms of privacy violations in context, realize that this stuff you're staring at happened almost a decade ago. Target used machine learning to identify and target pregnant customers. Apple put a secret tracking file on the iPhone almost 10 years ago, so it could track you. Google, Facebook, many others have created billion-dollar businesses on the unauthorized tracking of your web use, and still do. And Facebook, I don't know if you noticed yesterday, announced that they're going to delete their 1.5 billion person facial recognition database. That's the thing you use if you use Facebook to tag people. Technically, that's against privacy law. If my wife tags me in a photo, I haven't given her permission to do that. So that's against privacy law. They've got a lot of grief over it. So they just said, it's over. We're not doing tracking anymore as of yesterday. Amazon overcame the browser's security privacy settings through a weakness in Flash so it could track you. This is 10 years ago. You can imagine what the capabilities of these giant companies for doing bad things is right now. The power of AI has increased dramatically since then. This is what scares me the most about AI. And it's something you should consider for your own industry, and that's deepfakes. We see deepfakes in movies frequently. Princess Leia in the last Star Wars movie was done quite effectively, long after the actress Carrie Fisher had actually passed away. US presidents, famous actors, the Canadian emperor have been spoofed multiple times in deepfake videos in social media. But consider a world where you get a phone call from your mother and she says she's in trouble and needs money, and she needs it wired to her immediately. You converse with her and she answers back in context, in her exact voice. And you're absolutely convinced you're talking to your mom, that this power is real. There's an infamous story at Microsoft. It's never been made public. I don't mind telling you guys of a demo, an internal event where MSR, the Microsoft Research Group, they showed an interactive conversation between the virtual CEO, Satya Nadella, and the number two guy at Microsoft, Scott Guthrie, a virtual Scott and a virtual Satya having an interactive virtual conversation while the real Satya and the real Scott watched on stage in horror with their jaws dropped. Both real Scott and real Satya could started talking then to their virtual counterparts in context, in their exact voices. Machine learning was done on their voice patterns, on everything they ever said publicly in their keynotes and such, so that their virtual selves could answer and converse in context. This technology was immediately mothballed and never released to the public. This happened 2-3 years ago because Microsoft, it was too dangerous to get out into the public. Earlier, I showed you and talked about how facial recognition is a solved problem. I showed you how accurate it is, yet we have this controversy about providing it to our law enforcement personnel. This goes to Stacy's comment about artificial insanity. We have this perceived notion that it's an invasion of our privacy, or that it's actually racially discriminative, or that the technology is not good enough. So last year, over a 48-hour period, 3 of the largest tech companies in the world made announcements about getting out of providing facial recognition services. So what gives? Well, this is my opinion, just realize this, but I call this reversed ethics. IBM claims that the technology could be used to promote racial bias, so they are killing it. That sounds altruistic, doesn't it? But it's been proven that racial bias is just not true for the highest rated vendors by NIST. And NIST does racial testing on the algorithms. And guess what? IBM did not score well on any of the NIST testing. Actually, I'm not so sure they even qualified for submitting. And then an hour later, or a couple hours later, a few hours later, Amazon hopped on that bandwagon and said it's banning its own facial recognition technology for a year, only a year, which is coming up pretty soon. And that sounds altruistic too, doesn't it? But well, Amazon's facial recognition is the tech that was used in the controversial San Francisco Police Department pilot project. Amazon's facial recognition tech is so bad that the project was a complete failure. Naive politicians in San Francisco immediately assumed all facial recognition technology is bad and made FR for the San Francisco police illegal, making people less safe. NIST begged Amazon to officially submit their algorithms. Amazon declined. Notice the comment from the writer of the article. Critics called the 1-year moratorium merely a stunt. And then just hours later, the press starts figuring out that these look to be public relations ploys. The press started catching on to the PR ploys by these companies, jumping on the ethical bandwagon to avoid PR backlashes. Now, this is the one that bothers me. Because I've worked with Microsoft for so long, and I know Brad Smith, he's a great guy, but Microsoft hop on the PR bandwagon, and Brad Smith said, we're not going to sell facial recognition to the police. But if Tim Huckaby, if I could walk down to the street to the Carlsbad police station, I live in Carlsbad, California, by San Diego, and I could sell a facial recognition solution, build and sell a facial recognition solution, like I showed you earlier to the Carlsbad Police Department myself, based on Microsoft's facial recognition technology. And Microsoft wouldn't bat an eye. They would be making money on it because it's a consumptive Azure service. When you put it in production, you got to start paying for it. and it's dirt cheap, by the way. It's like 16 cents per 1,000 transactions. The transactions would be processing a frame from the video. And technically, Microsoft would not even know who was using it. And this just happened yesterday. I mentioned this. Facebook is ending the use of facial recognition software, saying it will delete the data on more than 1 billion people. It's almost 1.5 billion. Now you won't be able to tag your friends. Oh, well. All right. Unfortunately, this is part of our world. This is a real part of your world. I know way too much about what actually happened at the Mandalay Bay massacre in Las Vegas. This is not just a United States thing. It's an international thing too, of course. Let me tell you, we're using AI to help. In fact, this is one of the most proudest things I've done in AI. I designed and built a weapons recognition algorithm, but it wasn't easy and it's not perfect. It took almost a year of failing and learning and retrying, and it's still not good enough to where I would be satisfied with it. I built this for an ISV. Um, like software machine learning can always get better, but this is an impressive thing. I built this for an ISV. If this could be installed in every school or every casino that use common surveillance cameras that they already have in place, it would save lives. And this is where we're going. It will save lives. This is real-time weapon recognition. I'm not going to demo it. Technically, I'm not even allowed to demo it because I built it for another company. This is the screenshot of doing its magic, though. The US is not the only country with crazy people. There are crazy people all over the world. Imagine a world where surveillance cameras in every school parking lot has real-time weapon recognition, or in every casino. Because I know from experience in talking to you people that crazy people run into a casino with a gun in their hand. And in some Indian gaming casinos here in California, it may be true for North America, the security people are not allowed to carry weapons. It's a bad deal. In real time, you could automatically alert the authorities, and those seconds in dealing with it would save lives. Or in malls or city centers, this could save so many lives, and it will, from senseless mass shootings. Here's an example of an email alert or a texting alert or an API alert that's sent from the system using my weapon recognition algorithm. So notice on the right, it's identified a pistol with 90% confidence. Also note, this is my buddy Tony. That's a toy gun. Here's how difficult the police's job is. A toy gun has a red tip to it. You can see that red tip. In their real time, they have to identify toy guns versus real guns, and they do it by that red tip. Okay. So I like to explain AI to the non-technologists of the world, like my wife, in this manner. I compare it to nuclear power. In nuclear power, we got efficient, inexpensive energy. Shoot, we got the microwave oven out of nuclear power technology. It propels ships and cars and other type of things. That's the good news. The bad news, when the radiation leaks, it's a bad deal. It's lethal to millions. And there's many, many examples of that over the last 50 years. And it also produces the world's most efficient weapon. Well, in AI, it saves lives. It makes our lives easier. It automates menial tasks. It entertains us. But it can also replace low-skilled labor. And it's a tool for bad guys. I've showed you all this open source that is widely available to any bad guy that wants to use it. And it's a tool for bad companies and governments to track you. Wrapping this up. So there are no answers here. There's just opinions, and some of these points are the type of things you talk about in a bar with a beer in your hand. But these are tough questions. Are you willing to give up your privacy to be more safe? Before the pandemic, much of the privacy law all over the world, especially in Europe and the US, strictly restricted and prohibited unauthorized biometric analysis of the face. After COVID-19, in most of the world, you won't be able to go into any public place, office building, casino, retail store, airport, restaurant without a camera, without computer vision algorithms measuring your body temperatures, or doing a biometric analysis of your face. Do you trust the government to do a biometric analysis of your face in public places? Do you trust those communist countries to do it? Do you trust the United States to do it? We know that plenty of world governments have already done some tracking that would raise an eyebrow. After 9/11, the United States government and many governments in the free world just abandoned privacy law and did a ton of looking at people. Why do we have in the US, and I know this is true in Europe and Canada too, why do we have, do our privacy laws conflict each other? This is, if you would ask me as a technologist that I know anything about privacy law, when I first started this computer vision mission a decade ago, I'd say no way. But I know so much about it, it's scary. I know this is not as screwed up in Europe as it is in the United States, but the hypocrisy of having privacy law in the city you live in to be in direct conflict with the state you live in, which might be in conflict with the federal government, is ridiculous. Do you trust the Googles, the Facebooks, the Apples, the Microsofts, and the myriad of other companies that are looking at you, what's in your hands, what you're buying, and what you're searching on the internet? Shouldn't this be an opt-in thing? In a loyalty program, I absolutely would opt in. Let me think of a good use case. A use case would be, before the pandemic, I traveled constantly, and I would have to wait in line at the United Airlines club as people argued that they deserved to get in. When I had a membership, I would totally opt in to be facially recognized so I wouldn't have to wait on the line and I could just go right in. It's a great use case where I would opt in. There are a ton of use cases in your industry for your loyalty members to opt in to be facially recognized, so their experience at the resort, the casino, would be that much better. Do you believe my statement earlier? Humans make decisions. AI is just a tool to help humans make decisions. Insurance companies have not used humans in making policy and rate decisions for over 75 years. They rely solely on algorithms and mostly on their own custom ML example. It's well documented that a high-risk policy holder who moves from a ghetto-like neighborhood to a nice neighborhood because of financial success, and his or her policy rate is not changed because the color of their skin. This goes on today, where they were born, where they grew up, etc. How can insurance companies get away with these things? And finally, on this slide, because I gotta wrap this thing up, should developers have easy, free access to this stuff? We tend, in a developer audience, I always talk about being responsible. And if your managers or the people in their companies want to do bad things with the tech you build, it's your responsibility to raise a concern. So is AI the next nuclear weapon, or is it the next microwave oven? It might be both. And that's my opinion. All right, let's wrap this thing up because I'm out of time. This technology, I can't say this enough, has so much potential for the benefit of mankind. But with great power, AI comes with great responsibility. AI, machine learning, is on a growth curve because of how fast our hardware is becoming. A hockey stick-like growth curve in terms of performance and precision. There are many world-changing use cases for good, and there are exceptions that are used for bad. Computer vision is powerful. I didn't talk about the edge or the cloud, what I normally do in a technology type keynote. But moving this thing to the edge, the compute edge, without the latency of cloud processing makes this thing even more powerful. So there we go. That's it. That's all I got. If you want my deck, thanks for having me. Totally fun, although I didn't get to do it in person. If you want my deck, there's a URL at tinyurl right there. All right. Thanks.